circulates, I want you to go back and look at those pictures again.
The cerebrospinal fluid flowing through the brain has to be absorbed by the arachnoid granulations or into the dural sinuses?
It gets absorbed into the superior sagittal sinus via the arachnoid granulations.
Okay, thank you.
And we'll actually look at the flow of blood, the flow of cerebrospinal fluid through the brain here in a few minutes.
Yeah.
All right, now if you can recall from lab, there are spaces within the brain called ventricles. There's also kind of a channel, a tubular channel called the cerebral aqueduct. All four of these ventricles in the cerebral aqueduct are all interconnected, and they allow that cerebrospinal fluid to circulate through the brain, eventually out of the brain, and around the brain and spinal cord. Now, it's very important that we have cerebrospinal fluid because it does several things. Let me just talk about those a minute. Number one, it provides buoyancy. Which means that the brain and spinal cord are floating in this cerebral spinal fluid. So it makes the brain lighter, brain and spinal cord lighter, so that they're not physically resting on the bone of the skull inside the cranial cavity. One of the things they tell you when they say when you have an epidural, they say if you feel a headache suddenly, let us know. That means that they've punctured through the dura and the arachnoid mater, and cerebrospinal fluid is leaking out. And if you're losing fluid, that means that the buoyancy is less, and so the brain is actually going to start to settle and sit on the bone inside the cranial cavity. So that buoyancy is important. It's almost kind of in a weightless environment. Second thing cerebrospinal fluid is important for is protection. It's a shock absorber. Any bumps to the head, most bumps to the head, minor ones, that physical force of that bump or blow to the head is absorbed, that force is absorbed by the cerebrospinal fluid and kind of distributed so it's not damaging the brain. Now, in a real severe blow, where someone gets a concussion, what happens is, and this has to do with Newton's laws of motion, is if the head gets hit, okay, the brain keeps moving and it kind of sloshes and hits the side of the cranium inside, and the cerebrospinal fluid really can't do much about that with major head trauma like that. So concussions can result. So protection is a function of the cerebrospinal fluid. And then the final function is chemical stability. Any of the waste products produced by the cells of the brain and spinal cord end up in the extracellular fluid, and then they're transferred to that cerebrospinal fluid. And because that cerebrospinal fluid circulates and ends up back into the venous blood, those wastes then can be removed from the cerebrospinal fluid and keep the brain healthy, spinal cord healthy.
So the CSF wastes are removed from the blood itself?
The cerebrospinal fluid is removed from well, I'll show you.
Okay.
But the waste from the brain ends up in the cerebrospinal fluid, which then ends up in the blood. So we're removing that waste, keeping the chemical environment of the brain stable.
It ends up in the blood to retain stability.
So these are some views of the ventricle system of the brain. I know when you looked at your brain, did you look at sheep brains?
Yes.
You did? Okay. So when you looked at the sheep brains, you were able to see those lateral ventricles, right? Should have been.
Not real well. They weren't pronounced real well in the sheep's brain.
Well, here's your lateral ventricles. They kind of form this big C and kind of go into the back as well. here is the third ventricle here, which we know the walls of the third ventricle are made up by the hypothalamus and part of the thalamus and the pineal gland. And then here's the cerebral aqueduct. Here's that fourth ventricle. And then here's what becomes the central canal of the spinal cord. Here's another view, a frontal view, or an anterior view looking at it. Again, here's your lateral ventricles, third ventricle, cerebral aqueduct, fourth ventricle. Now here is an opening, and here's a couple openings that allow cerebral spinal fluid to circulate out of the brain and actually around the brain and spinal cord. So I'll show you those in a minute.
That's on the third ventricle.
I'm
sorry.
It's near the third and the fourth. Now here is a transverse section of the brain. Here again, you can see the lateral ventricles. Here is the third ventricle. Here is part of the corpus callosum there. And here is the